My name is Jason Rhodes. I'm the JPL WFIRST project scientist. And so that means I work with scientists and engineers on the JPL side to make sure that WFIRST is going to be ready for launch in the mid-2020s.
My name is Carolina Gilbert. I am an astronomer at Space Telescope Science Institute, where I am the WFIRST mission scientist.
So my career with the Hubble Space Telescope started when I showed up at graduate school in 1994. What happened was I was assigned a supervisor in graduate school, and my supervisor, his name was Ed Groth, and he had been one of the people that built one of the original cameras for the Hubble Space Telescope.
I first started using data and results from Hubble about 15 years ago, and that was to try to reconstruct the collision of a small galaxy with a neighboring galaxy, Andromeda, which is nearly a twin of our own large Milky Way galaxy. I started working on WFIRST nearly 4 years ago, and my primary goal for WFIRST is to maximize the breakthrough science that it will do across all of astrophysics, from the solar system to the edge of the observable universe, just as Hubble has.
Hubble Space Telescope was really transformative for the astrophysics community. And the way I like to think of it is one of the first things that everyone learns about astronomy is the song Twinkle, Twinkle, Little Star. We all learned that as a kid. And the irony of that is that it's not actually the stars twinkling, it's the starlight coming through our atmosphere that's causing that twinkling. And that twinkling of the starlight makes it harder to measure things like the brightness of stars or the shape of galaxies. And so what we want to do is we want to get outside of our atmosphere so we don't have to deal with that twinkling. So Hubble was really the first telescope that rivaled ground-based telescopes in size and capability that was above the atmosphere and got rid of that atmospheric twinkle.
It turns out that we found that stars extend many, many times farther out than the centers of galaxies where Hubble is really good at looking. So in each image, WFIRST will cover an area of sky 100 times larger than Hubble does, and that will allow us to survey the outskirts of galaxies, to measure their true extent, to discover streams of stars that indicate where small galaxies fell in and were torn apart by the gravity of bigger galaxies. And we will make these measurements for hundreds of galaxies in the nearby universe.
So one thing I learned from working on Hubble that will translate into WFIRST is, as scientists, we have to be patient. It can sometimes take a really long time to process and understand our data, the images that we take. And in the same way, it can take a long time to plan and build and then finally fly a space telescope. I was lucky enough to start my career on Hubble having the data already, having the images already, but it took me many years to process and understand what was in those images. And I've been working on WFIRST under one name or another for 18 years. And so that patience I learned working on Hubble has really paid off in being patient and persevering with getting WFIRST going.
One thing I've learned from working on Hubble is that the universe will surprise us, and astronomers will be more creative than we can anticipate. Astronomers have continued to think of exciting and unique questions to answer with Hubble for 30 years, and now many astronomers are answering entirely new questions using existing data in Hubble's archives. Since WFIRST will be like having 100 Hubbles all pointing together, and this massive amount of data will be available right away, from day one, scientists from around the world will use data from WFIRST archive to explore questions that we have not yet imagined.